So why doesn't this work in real life? The simple answer is that it's just too complicated. It's a lot more complicated than we're making it. So one of the things is that there's an inherent bias in sampling. So when we go and we're looking at the different species of the lichens and we think we've got them all, we inevitably have missed some somewhere. And so we have to sort of hedge our bets and make sure that we pick several areas in case there are other species. One of the biggest issues is that we're only modeling the preservation of one species, the lichen. But what about all the other organisms that we might be destroying in the process of eliminating their habitat? So trying to do this simultaneously for all of the species that are there is quite complicated to do. The next thing is that if we were to look at them all together, it's really hard because a lot of times the different species don't need the same amount of area. So like if you're trying to preserve caribou, it's a lot larger space than if you're trying to preserve a lichen. And so that makes it even more complicated. And then functional redundancy. So you might say, well, you know, this particular species serves this ecosystem service, and this species serves the same ecosystem service, so do we really need them? But you don't necessarily know if that particular species is serving other ecosystem services that you just aren't aware of. And so like mosquitoes, right? We want to get rid of mosquitoes because they carry malaria and they don't seem to serve other purposes, but there are other organisms that rely on mosquitoes for their diet. And so if we eliminate them, we might actually eliminate other species. So the point is that it's very complicated as we try to make these decisions, and you can't just do it based on one favorite species that you might have. And so we have a lot of complicated modeling systems and people who are trained in this that try to make the best decisions based on all of these variables.